Good morning, sir. My name is Saurav Jadhav. Today I am here to give my ISC2 of subject heat and mass transfer. So, ISC2 topic is to design and analysis of compact heat exchanger system for domestic water heating. This is our problem statement. These are the given parameters. My roll number is 42. That's why we are taking mod of 42. 42 mod of mod 3 is 0, 42 mod 4 is 2, and 42 mod 5 is 2. We are calculating mod by reminder. 42 is divisible by 3, so that's why 42 mod 3 is 0. These two are as for. Here is diagram of our problem statement, where this is a counter flow diagram. Cold fluid inlet is from here and cold fluid outlet is from here. Hot fluid inlet is from here and hot fluid outlet is from here. That's why it's called counter flow. Here is graphical explanation where the hot fluid inlet is from here and hot fluid outlet is from here. Here we can see that how fluid temperature is decreasing as per the length increasing. Cold fluid inlet is from here and cold fluid outlet is from here. We can see here that the temperature of cold fluid is increasing as per the distance increase. So these are design parameters. So inner pipe diameter is 12 plus mod 4 is equal to mod 4 is 2. That's why 12 plus 2 is equal to 14 mm. Inner pipe diameter is 14 mm. Outer pipe diameter is 24 mm. Tube length, we know the formula that is tube length is equal to 1.2 plus 0.2 into mod 3 is equal to 1.2 meter. 1.2 and 0.2 are the given parameters. Cold fluid inlet temperature is 32 degrees Celsius, hot fluid inlet temperature is 75 degrees Celsius, and flow rates and Cp are same as given. So heat transfer, we know that heat transfer is Q. So we know the formula that Q is equal to MC Cp in bracket TCO minus TCI. That's why Q is equal to 3.77 kilowatt. Capacity rates. So capacity, we know the capacity rate formula, which is Ch is equal to MNCP. So we have calculated capacity rate is equal to 157.5 watt per Kelvin. We have calculated Cc, which is 209.3 watt per Kelvin. We have to calculate Cr, which is equal to C minimum divided by Cc. So Cr is equal to 0.75. C is effectiveness. So we know the formula of effectiveness is equal to Q by C minimum in bracket Thi minus Tci. So we calculated effectiveness is equal to 0.56. So overall, next is the overall heat transfer coefficient. Overall heat transfer coefficient is equal to U. 1 by U is equal to 1 by Hn plus 1 by Hh plus 1 by Hc. So U is equal to 25.8 watt per meter square Kelvin. So next we have to calculate area using Q method. By this formula we have calculated area. So area is 1.21 meter square. Next is LMTD method. Hot fluid outlet temperature. We have to calculate LMTD method. We know that Q is equal to MNCP in bracket Thi minus Tho. So by this formula we have calculated Tho means hot fluid outlet temperature is 51.1 degrees Celsius. So there is a temperature difference which is delta T1 is equal to 75 minus 50 degrees Celsius is 25 degrees Celsius, and second temperature difference is 51.1 minus 32 degrees Celsius is 19.1 degrees Celsius. So in LMTD method, total temperature difference means delta 1 minus delta 2, delta T1 minus delta T2, which is 21.9 degrees Celsius by LMTD method. So we have to calculate area by LMTD method. So we know the formula that A is equal to Q by L LMTD. So we have calculated area is 12.60 meter square. So available area, we know the formula that A is equal to pi dl. So available area A is equal to 0.0527 meter square. We are comparing here required area and available area. So we required area is 0.6 meter square and sufficient because the required area is more than available area. So we have selected the material selection. We have selected material aluminum because it has a good conductivity, it is lightweight and low cost. We can perform this overall design and the calculation. We conclude that the heat transfer is 3.77 kilowatt. Effectiveness is 56%. Required area is more than available area. System is thermally feasible but geometrically is insufficient. We have also calculated cost constraints. Components are aluminum inner tube and it costs around 350 rupees. Outer casing unit cost around 450 rupees. Fitting connectors is 250 rupees. Insulation material is 150 rupees and fabrication which is so total design cost is under 1,500 rupees. So we justified that we selected material. Selected material is aluminum because it has a high thermal conductivity, hence better heat transfer rate. It is lightweight, corrosion resistance and low cost. It is a balance of performance plus cost plus durability. Limitations are available. Heat transfer area is 0.05 kilometers square, which is less than the required area. Short tube length reduces effectiveness, moderate overall heat transfer coefficient, and pressure drop may increase